The following content has been provided by RWTH Aachen University.
So today, we're going to cover two things. First of all, we're going to jump right in and talk about Swift and give you a quick introduction into some basic programming fundamentals of the Swift programming language. And we're doing this, knowing that you guys know what programming languages are and that you're all familiar with a couple of programming languages, at least things like Java or C, those kinds of things. And so we won't be going from scratch, assuming that you've never seen, a while loop or anything like this. So this will be Swift, just as the language suggests. So keep up with it, and we're going to point out the specialties of this language that you need to get familiar with. And after that, we're going to actually do a little presentation also of the Xcode programming environment. Phil will take over from there and show you how to handle Xcode, the IDE of Apple, to write macOS and iOS applications. And the third part today will be about the seminar topics. So we're going to have a quick rundown of the topics that we've got available for you guys to pick for your seminar section. And you'll be able to get an idea of what's out there and what you might be enjoying to dig deep into. As usual, remember the jump page down there at the URL is your one-stop shop location to go to if you need any information before you send emails to Phil. Check out what's up there and also check the Moodle forums. Okay. So right in, quick recap. What did we talk about last time? We covered things that had nothing to do specifically with iOS or Swift, and we tried to give you a general feel of what it is about to develop for mobile, because this is a very different beast than writing apps for the desktop or for people working at a desktop or laptop environment. Remember that one of the key things that's different about mobile application use is that they're used in a wide variety of contexts, right? Out on the street while walking, while chatting with friends, at a table in a bar at night. All those kinds of situations are quite different from what you're typically used to writing applications for the desktop. And then, of course, there are technical differences that are obvious, like the screen size, battery requirements, those kinds of things, but also fundamentally different metaphors. Like we don't have overlapping multiple windows that we can easily switch back and forth on with a speedy mouse pointer, right? And that actually has quite a few implications on how you can design good applications for mobile environments. And then we looked at a few things that were a little more specific to iOS, although they also, I think, have good applications if you look, for example, at Android or other mobile Windows systems. And one of the things that we identified were these different application styles. In particular, iOS, the human interface guidelines divide the landscape up into three kinds of applications. One is a very basic productivity application class, things like mail or the contacts application, or even photos, although you are dealing with media, but the whole structure of it is for productivity, for utility, mostly, where you're trying to handle large data, large amounts of data in usually in a hierarchical fashion. And then there was this is also the class that uses most of the standard UI toolkit that Apple provides. The standard buttons and things like that. Then the utility apps are sort of a little more playful, a little more immersive already, very much geared towards only doing one tiny thing and doing that really well, like showing you what the weather is like. They hardly use standard controls, although there usually are a couple, like for example, the three little points at the bottom for swiping through different pages of the app. And then there's finally the big section of immersive apps that completely usually do away with your standard user interface controls that Apple has predefined for you, and that roll their own, basically, to immerse you into a fantasy world, whether it's a game or whether it's flying through space in a simulation, whatever it might be. Okay, so those were the key things we talked about last time. And now I want to move on and talk about Swift. Swift is the language that was introduced at the Worldwide Developers Conference, or WWDC, by Apple in 2014. This is the annual event where Apple gathers its developers around. For the last couple of years, it's been online and free for all to attend, and I highly encourage you to check out some of their videos. This is basically straight from the horse's mouth, as they say. So if you want to know something about a new, or maybe even a not so new framework, how to really use it, this is where you can catch the Apple engineers telling you what they were thinking about and how they designed this thing and how it's supposed to be used. These videos are also available for you to access for free if you've signed up as an Apple developer. Swift is a new language. It was heavily influenced by C and its objective-oriented cousin, Objective-C, but it was designed to be much easier to pick up and start working with, and also not to heavily depend on backwards compatibility to older languages. So, for example, if you take C++, it's a language that you can write C code in C++ and it's still valid C++ code, right? Similarly, actually in Objective-C, that's also was a much smaller layer of object orientation on top of C, also quite an elegant language in its own right, and the one that had been used by Apple for many, many years to implement applications, basically ever since Mac OS X came around the turn of the millennium, so 20 years ago now. Everything was being written in Objective-C. But we're cutting off those old threads, and with Swift, we're having a new start, which was really timely because we've seen so much involvement in innovation in programming languages that it was a good idea of Apple, I think, to start new and give, also by doing that, a much broader area of people the chance to actually pick up developing applications. Swift is now, quickly became open source and is now actually replacing Objective-C throughout iOS and Mac OS as the primary language that you use for coding. You'll find probably that it is quite, compared to other languages, quite easy to learn, quite easy to read, and that was actually a fundamental design goal of the language, to make it so that it's easy to read code, easy to write without too much, syntactic unnecessary sugaring, and also for maintenance of applications in large code bases. Some of the characteristics that you'll find in Swift is that the syntax is pretty cleaned up, which makes the code easier to read and to work with. You'll find type safety in there, which means that it actually enforces code that is less likely to ultimately, crash at runtime. And it uses type inference, inferring a type of a variable for you, so you don't actually need to spell it out. If you, for example, declare a variable and immediately give it an initial value, Swift will figure out what the right type is that you want to use. Of course, you can override this, as always with these things, but that's the default way that it works. This really speeds up development. It also helps the compiler to find common mistakes that you might make. So type safety, type inference together, type safety is basically restricting you a bit, but the type inference, again, removes a lot of the burden of keeping to these rules of type safety. And unlike other languages that leave you completely open to imagine whatever type you might be using, this gives you actually pretty robust runtime code where you'll have to struggle a bit more to get it to compile, but once it does compile, you've got a much lower chance of failing miserably when the user is actually running the application and it suddenly crashes. The other thing that's in Swift is automatic reference counting. And this is a memory management technique that you may be aware or familiar with. Basically, we've seen three large historical versions of how memory was managed in apps. The original way that you, for example, encountered if you've used C or C++ was you do it yourself, right? You have to actually assign and release memory yourself with little, special commands in your language. And that is incredibly fiddly to work with. It requires a lot of disciplined coding. And it was one of the reasons why, since also Objective-C in its original years requires you to manage all your memory yourself, it was really hard to get on board with writing applications for iOS and macOS, I should probably say. Now, when Objective-C then, or we should say Java, for example, solved this differently, right? And you've learned Java if you're from the bachelor's program here, and that completely removes that requirement from the developer. You've got your automatic heap management, and it occasionally goes through and cleans up, and you don't have to think about this at all. However, that can also, those cleanup cycles can also hit your application when it's about to do something really time critical. And so you're a bit too disconnected from managing memory. And it also poses a few challenges if you want to write highly performant and space efficient code. So with Objective-C, actually, Apple introduced ARC, automatic reference counting, which basically is like manual memory management. So it's only assigning memory when it needs it. It releases it at the right time when it should go away. There's no big sudden cleanups going through that that might slow your program down at runtime. But it inserts all these commands for allocating and freeing up memory, allocating it, releasing it. It introduces those commands into the program in a pre-processing step for you. So you don't need to do it yourself. It figures out what you need to do. So it's kind of like, somebody looking over your shoulder saying like, oh, this is where you should allocate some memory. This is where you should release it. I can't tell you how much easier this makes your life as a programmer. So you don't need to deal with the challenges of memory management in 95% of the time. When you write really tricky code, you may end up having to tweak what Apple is, what the compiler is suggesting for automatic memory management, but most of the time you don't need to worry about it. So you get the benefits of an automatically managed memory solution like in Java, but you get it with a much better runtime performance without the problems of suddenly something coming through and sweeping all memory at an inopportune moment for you. And then finally, another thing that's also weird or special in Swift is optionals. We'll talk about it a little more. It's a new way of expressing when values may not exist. You may sometimes have variables that can have a value, like a number, like an integer, but you may have situations in your code where you can't associate any reasonable number with the variable yet, because it hasn't been specified yet by the user, for example. And this is often handled with a nil expression. And again, Swift makes it much, much safer to work with these kinds of situations. We'll see how that works in just a second. A few other things that are interesting here is that, for example, Swift actually allows you to handle tuples of values quite naturally. So tuples are just a group of things, you could related to arrays or sets, but a little different, because tuples can actually contain different values of different types within a single, tuple. And these can also be, you can also return multiple values from a function that way. Right? You can get back not just one thing, as you usually can with, for example, C, but you can actually return a whole bunch of things in a single function. Generics, again, is something that you may be familiar with from other programming languages. They help you writing code that you can use in many different scenarios, right? By adopting from this kind of template style writing of a data type to apply that data type, that more abstract data structure, to a variety of base types. This is a standard thing that you'll be familiar with, and it will just show you how it works in Swift. Collections are, as you would expect in a modern programming language, collections are fast and very concise code to iterate over. So it's very easy to write something that iterates over an array, for example. No more messing around with having to have an index variable and count that from 0 to the length of the array -1 and blah, blah, blah. It'll just iterate over the array, and that's exactly what you write. So that's, I think, what you would expect from a modern programming language today. Then an old familiar will make a return, and that's the struct. Those of you who still have, original C coding blood on their hands may remember structs as being, quite a quite a frequent part of code in writing C. But once we moved to object-oriented programming, especially with C++ or even with Objective-C, for example, or Java, structs kind of went away, and they were pretty much, most of the uses for struct went away because you wanted objects, right? And we will see that structs actually come back with a vengeance in Swift. And I'll explain why that is the case. It's quite an interesting development and quite an interesting design choice. That throws an interesting light also onto what's expensive in terms of runtime today when you code. Things have really changed in the last couple of years and decades. And structs, you will find, actually support things that you would normally associate with objects or classes, like methods, extensions, even protocols. Well, and then we have things like map, filter, reduce, and other programming patterns that have also made their way into modern imperative programming languages from the functional programming world. That will just show how they simplify code and streamline a lot of typical actions that you would have to do earlier on in many lines of code. And finally, error handling is pretty powerful in Swift. Helps you write code with fewer bugs, of course, and better handles situations where an application might crash or behave unexpectedly because the users entered something that your code can't process in the normal way. But that's enough talking about theory. This should just give you a feel for Swift. It's a lot of fun coding in Swift and learning Swift. I found this is a very enjoyable thing to do. And it actually, just as an aside, I think in a way, languages like Swift are fixing a problem that we faced for easily 20 years. Because when computers became popular originally in the 80s, for everybody to have at home, you turned the computer on and it presented you with a basic interpreter, right? You could start coding immediately. And this created a whole generation of people for whom coding was just a natural part of using a computer. I'm one of those people, right? This is how I learned coding in the 80s on a little tiny home computer. And that created a level of, I think, technological skill that ran through an entire generation of people. And we sort of lost that opportunity. If you were at that age and you bought 15 years later and you bought a Windows 95 computer, you could turn it on, but there was no basic interpreter greeting you and asking you to write code. You were running apps, right? You were installing applications. Well, yes, also games. We all play games, but this writing code for yourself and actually building apps became harder. The level of complexity in software rose, and so rose the threshold of entering that realm. And only recently, I think we've seen a return of the self-taught home at night kind of like sometimes even teenage kid coder, right? These days, the tools that, for example, Apple makes are so carefully designed to be pretty easy to start playing with, even if you haven't studied computer science, that we may face a situation where we're bringing back the general skills of understanding what it means to write applications, or what it means to code into the broader public. And I think that's very important, socially speaking, because more people should understand what computers can do and what they cannot do. Otherwise, how are they going to, understand what AI even means? So I think this is all great, and it's a second sort of springtime for home coders. So beware, because you are all, of course, professional coders that you're going to be. You're all learning this properly at a university, but you will find, I think you will benefit from this, because even as an experienced developer, you will probably enjoy the ease with which you can get into coding and writing applications on this platform. A lot of things are laid out for you, tools are available that make this really easy. And I will show you the first tool right now. For that, I'm going to briefly switch over to a different application here. Let me do that. All right. And let me share that screen with you. Yep, you should now be seeing my terminal screen. Like I just opened a terminal in macOS on my MacBook here. And what you can do in the terminal is you can type in Swift. and that will launch the REPL. The REPL is the Rapid Evaluation and Print Loop. Note, I haven't launched any IDE. I haven't done anything like that. The REPL is basically an interpreter that will take Swift commands and execute them, right? So I can type in things like, var x equals 7. And it immediately tells me what I did. Hey, you just created a variable x and its value is 7. And by the way, the type of that variable is integer. That's one of the examples of inferring the type from what number I gave it. And now let me, if I say, set x to 8.5, it's not going to work because, I can't do that. And it immediately tells me, hey, I cannot assign a value of type double to type int. So this is great, right? This is a wonderful tool. I wish this had been around when I was learning to code, right? Because this makes it so easy to just try out language examples without having to boot up Xcode or anything. So make use of this, type in Swift at the command line and put in all those things I'm going to show you over the next couple slides and try them out, see what happens, see what the interpreter tells you. This is really a convenient way of playing with Swift. All right, let me go back to my slides. All right, we should be back in business now. So this was my example of the terminal, right? You can just type that in, and if you want to get out, by the way, you have to type : quit. That's the only thing that may not be entirely obvious. That gets you out of the out of the Swift REPL. So the next thing you can do, still, you don't actually have to launch Xcode. There's a way to do that without Xcode. There's a separate application for this called Swift Playgrounds, although there's also a way to open up a playground in Xcode. Phil will show you this later in the demo coming up in the second part of this class. But just to mention this is the next level up where you, rather than just typing in a few lines of code and seeing what the bare metal language does, here you can actually write entire applications. And well, you wouldn't probably do large software projects with this, but it's a great way to write some simple tools, to write some simple pieces of code, and to see how it works. And it's so great to work with this, right? See, every line you type in, it'll actually tell you what the right side evaluates to, right? You can see, oh, if I type var greeting equals hello playground, that tells me that this evaluates to hello playground, because that's what the evaluation of this assignment does. And then if the next line says print hello world, I can see that would actually output hello world. And by the way, it would also output a carriage return, as you can see there, a new line character, because that's inherent, it's implicit in writing a print statement without any special formatting. And at the bottom here, you can literally see the output hello world as it appears on the console. So this is your basically, REPL on steroids. This is your rapid evaluation print loop. Much better. You can write lines of code and you can run them by hitting that little play button, and you can see what they do. Fantastic to work with. And if you hover over these little things here, you can even explore if this, let's say it's a tuple that you put in there in the as an assignment, you can even explore what's inside that data structure. So it's kind of like a little lightweight debugger right there for you to play with. Really, really useful and really, really great for anybody to just pick up coding with Swift really quickly. Okay, so let's talk about a couple of things that are unique in Swift, right? The first thing actually is unique at a quite fundamental level, and that is how you deal with variables. We're all familiar with how you declare variables, int x, for example, to declare an integer variable in many languages like Java, for example, that you might be familiar with. It's a little different in Swift, and there's a reason. The reason, there is an actual keyword called var, right? This needs to go in front of a variable declaration, and here we declare a variable x, and we also set it to an initial value immediately. This actually will refer back to a design pattern in Swift that I'll talk about in just a minute. But why is there the var keyword? Well, because there's also let, right? So constants are defined using the let keyword rather than the var keyword. And constants obviously are things that, once you've assigned an initial value, you can no longer change. We're very familiar with this concept, but it really, really has a much more important role to play in Swift than in other languages that you may be familiar with. One of the design patterns of writing Swift applications that Apple heavily pushes is to use constants whenever you can in your code, unless you really need to change that value later on again. You know, we often write code and we just need a little helper variable to help us figure out how to, what the immediate value of an expression is and to pass it on to somewhere else. But we're not planning to really change that variable later on, right? And whenever that happens, Swift is asking us to use a constant expression and just to do one initial assignment to it and then no longer change it. Because again, the compiler can do much more efficient optimization if it knows that a variable is no longer going to be changing. And it also makes your code much safer, because if you do use constants and then you later on you try to change it, although you really weren't planning to, the compiler will let you know. So this is really, really useful. Here's an example that's done right inside Swift Playgrounds. Oh, by the way, I put a little marker here, this little monitor and the exclamation mark, not because it's a mistake, but this is supposed to point out Swift-specific design patterns that, as a software engineer, as computer science student, you should be aware of. These are the unique things, when you tell your friends about Swift over a glass of beer or Apfelschorle tonight, these are the things you want to bring up. These are different, okay? So what does that look like? Here's an example. Let's say I launch the Playground, and let's ignore the import Cocoa for a moment right now. And you define a constant x and you assign a value 1, and you define also a variable y and you assign the value 2 to it immediately. And then we can change the value of y later on, right? We can set it to 3, no problem there. It's as you would expect. But if you try to change the value of x, of course, it's a constant, and the compiler will actually, the editor will tell you very quickly. In the Playground, you will be yelled at immediately, basically, that you cannot really do that, right? Because x is a let constant, that's what it's called. And these let constants will appear a lot in Swift when you work with it, okay? So that's the design pattern number 1 that you want to remember. Really use let whenever you can, and let the system point out to you if you are ever trying to change a let constant later on. Because then you can figure out whether you actually wanted to or whether you may have made a mistake there. The next design pattern I want to talk about is type inference. Now, it's weird. I didn't give you an example of declaring a variable without immediately initializing it, right? Well, and the reason for that is because that's a very, very common way in Swift to write code. Why? Because if you already have a meaningful value that you can give to a variable upon declaring it, then Swift will derive the right type for you. And it will derive the simplest, so smallest, least memory footprint intensive type that it can find to take that initial value. So that's why, good Swift coders, whenever it makes sense, will immediately assign values, and they won't even specify the type. They will let Swift figure it out. For example, here, I've got a variable, x, and I give it an initial value of 100. Note that the 100 is an integer expression, right? So the compiler says, all right, looks like an integer. I will make x a variable of type integer. If you then later on try to make x into 99.5, it's going to throw an error because, that doesn't fit into an integer variable. If you did it the other way around and you gave it first a variable, if you wanted to fix that, you would actually have to say x equals 100.0, right? That's actually something very common to find in code. Rather than writing the explicit type, I'll show you down there how that works. People often just, make the initial value so that it represents a right side expression, an R value of the right type. The other way around, of course, it works fine, right? 99.5 is obviously a float value or a double value, actually. And then that will be the type of x. And then later on, you can certainly throw 100 as an integer expression at the double value. It will be turned into a double 100.0 value, essentially. And x will remain of type double and everything's fine. Now, there are some situations where you may not want to do that. First of all, there may be the case that you, let's say, you have to define a username as a string, and initially you don't know what the user's name is, and you want to declare that variable, but you don't have a useful value to give to it yet. You can just declare a variable and not give it a value. You can see down there how you do that, right? You say var, because you're certainly going to be changing it later, a string colon string, and that's kind of how you write types, right? So a string is a variable of type string. Another situation where you might need this is if you actually needed to overrule what Swift was deriving as the type from your initialization, right? If you if the inference that Swift makes is wrong, then you can fix that by giving both a type declaration and an initial value. For example, well, you will see actually some examples on the next page. I think that's easier to explain when you see it. The third reason why you might not initially have an initial value for a variable is if you've got your own complex custom data structures like classes, or as I said, structs will also come up oftentimes, that you typically don't initialize directly with the starting value. Then you use that way as we did it down here. You specify a variable colon and then your custom type that you've defined earlier on without an initial value. Because this is such an important design pattern, here are some more examples. So x1 equals var x1 equals 100 will make x1 of type int, right? Very easy. X2 is a double, again, because the way it's initialized. If you now say var x3 equals x1 plus x2, that will actually throw an error, and that can throw you off. Now, this is something to remember. When you've got two variables of different types, like int and double, Swift won't automatically and silently just cast those into double, which it would have to do in this case. It will complain. And that's because it wants you to say explicitly that this is what you want, right? This is all about writing safe code and knowing exactly when you are typecasting. So you can do it, but you have to put double x1 in front of it. And that's a slightly different way of writing it that you might be used to from Java, for example. But this is how you write it in Swift. And then everything's fine because now the right-hand side expression is double plus double, no problems here. X3 is then inherently, implicitly derived to also be of type double. Curiously, though, the next line works as well. 0.5 plus 100. This is for Swift a case where you have explicitly spelled out on that very line that one of these things is a double value and the other one is an integer value. And in a way, the compiler wants to be picky, but it thinks if oftentimes when something happens right on that line, it actually won't complain because it assumes that you know what you're doing, at least as long as it's only about the current line, right? So here it's very clear that we want one, double value and one integer value, and so adding those literals together works because there the automatic cast to double will happen. So the addition happens, and then that turns out to be a double value. And that you can then assign to x4, which will also then, of course, be double implicitly. So if we did an output of that after that with the print statement, we would actually see an output that says x4 equals 100.5. And of course, we're using a very locally, very highly relevant floating point number here for that particular number that you guys from Aachen are all aware of. I should say that this line with the print statement also explains to you how you actually output variable names or expressions in general, right? You can see what we do is we write a backslash, and then in round parentheses, we write our expression. In this case, just the name of the variable, and that'll insert the value of that variable right there. We don't need to go through the hoops that you may know from, for example, C or even Java with the special format strings and so on. That's not necessary. It'll work just like that. And that's also a very common design pattern. You'll see that used a lot. And finally, the last line has two interesting points. The boring one first. If you write a string on the right-hand side, of course, the variable is derived to be string. The more interesting one is you can actually use emoji characters in your variable names. Not that I would recommend it, okay? Not a great idea for posting your code anywhere in a BBS or on Stack Exchange and then messing things up. And then, so be careful about this. To this day, I'm highly hesitant to do anything but 7-bit ASCII in my variable names or anything like that. It's sad. It's 2021. We should be further ahead than that, but we're not really. All right. Okay, now I would like you to fasten your seatbelts, because now comes a concept that's a little trickier to actually wrap your head around. And that concept is optionals. And if you've dabbled in Swift at all, then you'll know that, what I'm talking about. This is not trivial to understand. Let me start with the following. The gentleman who invented the nil, the concept of nil as something you can assign to a variable, later said that this was probably the worst thing he ever did for the computing community and for the the world community of programmers all around the globe, because it has led to no ends of suffering and pain and tears and so on. Nil is very useful in many situations when you don't know what a value is or you don't have a useful value to give it, but it's also incredibly tricky to work with. And if you have, by any chance, worked with Objective-C, it took like the completely opposite approach of Swift. In Objective-C, it was perfectly normal that a method would return nil, for example, and you could use that, and you could run actually another method. Yeah, Ali is like, yeah, I've been there. And you could use that nil and actually, could use that like an object and try to run another method on it. It would be fine. It would just, again, return nil. Right? So this is very, very normal to have nil all over your code as an intermediate result, passing it back and forth. But boy, you had to be careful and pay attention, because one reference to that thing where you're not aware that nothing actually is there, and your code would blow up at runtime, right? So it's really dangerous territory. So the way that to fix this, to have a way to express a variable type that can also have no meaningful value at a point, which makes sense, but also have type safety and runtime safety, is optionals. By default, if you declare an int or any other kind of basic data type that Swift provides, these variables cannot be nil, right? If they are, things will blow up. And if you try to sign that in your code explicitly, it won't let you. So, but you can have variables like an integer variable that can also be nil, in the sense of I don't have a useful value right now. And that's optionals. The way you do that is that you say, for example, here var I equals 3. I give it the type name int, but I add a question mark behind that. This means the variable I can now be any number, like an integer can be, or nil, right? And now I can assign nil to that variable and nothing's going to happen, right? It's fine. It's allowed to happen. So far, so good. It's easy enough to understand. But you got to be aware that because optionals can be nil, there are a lot of things that these optionals, if they are actually nil, couldn't do, right? For example, it doesn't make sense to print a variable that doesn't have a name, right? What should I print out when a variable has no value, right? There's nothing to print. So in a lot of situations, these optional variables will not be compatible to their base type. Like int optional is a lot of times not compatible to int without the optional. A couple examples here. I've got a function in Swift that's capital int and then in parentheses 42 in the string. What that'll do is basically take the string that it finds and parse it and look for an integer value on there. If it finds one that it can read and interpret, it'll assign that integer value and return that, right? It will basically just return the number 42 out of the string. But the string could also just contain, garbage, and there might not be characters in there that make sense as a number. So in this case, int will return nil because it didn't find a number, right? That makes total sense. Now, if you assign that to a number variable, the inherently derived type will be int optional, right? It will be an optional integer because it could be nil. So far, so good. But now if you try to print that, print won't let you because it says, I can't print an optional integer. Sorry, because it might be nil, and then I don't know what to do. So I won't let you even compile that. Also, you can't just assign that to an integer variable by the, and thinking, okay, so let's ignore the nil case, and then in all these other cases, this is going to be fine. No, it doesn't work, right? So there are ways to explicitly get optionals to become regular values when you know what you're doing, and you can be sure that they are not going to be nil in a particular situation. But that's a longer story. I don't want to throw this at you right now, but be aware optionals are going to be a big topic. And they are a tricky beast, right? So they will need a little bit of your brain juice to actually understand. A little bit easier is the concept of, I should say, optionals are used a lot in Swift APIs, okay? So a lot of methods like the int method here, for example, will just return optionals, so be aware of that. Now, tuples are easier to understand. I mentioned that they are basically just a special type of variable that can contain several elements, like a set on array, but these are a struct, but they can actually be different types right in there, right? So a tuple can be 42, 23.0, the string hello, and the binary value true. And then you can actually do things like var, and then you specify 4 variable names, A, B, C, D, in parentheses. This is pretty weird, right? For somebody who comes from Java or anything else that's based on the C family of languages. And you can assign that to tuple. Oh, sorry, so you can assign tuple to that. And that will automatically set all these 4 variables to their corresponding values from the tuple. It's pretty nifty. It's clear what it means once you look at it, but it looks strange if you don't know Swift. Also, you can access the components of a tuple by their number. Tuple.to, for example, will access the string hello because, of course, they're 0 indexed, like pretty much everything in programming languages today. So tuple.0 would be the 42 here. Okay, so those are tuples. Next up, and this is simple stuff, nothing complicated here, but there are 2 small details here that you need to pay attention to. First one is the if-else statement just looks the way that you would expect it to, except, again, if you're a Java, C, blah, blah, blah programmer, there are no parentheses around these expressions, okay? So that might, maybe confuse you. You're not going to break anything if you introduce those parentheses, I think, but you might find a lot of code that doesn't have them. And then there's you can use the normal operations, double ampersand for and double vertical bar for or, exclamation mark for not, all that kind of stuff that just like in Java, for example. And then there's the ternary operator, where if you had a function that you were, or if you wanted to write code that determined, the larger of two variables and assigned that to the variable largest, these first couple lines will be what you would normally write, right? You'd declare a variable largest of type int, and then you'd have 2 constants in this case because we don't need to change those. There are 15 and 4, and depending on which one is bigger, we assign largest to one or the other. Sorry, we assign one or the other to largest. I keep saying that wrong around. And we can write that in much more compact form. Again, this is well known from C and friends. Largest equals if A is bigger than B, then use A, else use B, right? This is a typical notation that I think you're familiar with. All right, in control flow, again, nothing too exciting, but small details that can trip you up. For example, the switch statement exists just like in C and friends, in Java, etc. And here's an example, right? We've got a variable that we assign to a tuple, 0.0, comma 0.0. So that's a 2 tuple with 2 double values inside. And we can now switch on that, which is cool by itself already. If you think about it, we're switching on a tuple variable, right? Not just a base type of int or something. And then we've got our case statements. If the tuple is 0, 0, then we print out the word origin. If it's anything else but 0 on the right hand side, and it will print out something on the x-axis. If it's 0 but anything else on the right hand side, we print out on y-axis. And there's a default which says the point is somewhere else. Now this works because, and this is where it's different from Java and C and so on, there is no explicit fall through. The fall through doesn't happen automatically. Sorry, that's what I was saying. So no implicit fall through, meaning after that first case statement is done, if it was fulfilled, if that first condition was fulfilled, Swift does not continue to the next one. Right? It automatically leaves the switch statement and goes on beyond. So these are really exclusive cases. Only one will trigger, and only the first one that is a full match on what you give it will trigger. And this is why this code works, right? Otherwise, this would not be possible. So we'll first check whether both variables are 0, 0. Then we'll print origin and leave it. And only if that's not the case, it will get to these others. That's just something to be aware of. The other thing you need to be aware of is the switch statement. The switch case statement needs to be exhaustive, right? All cases need to be covered. If they're not, then the compiler will actually yell at you. So that's why you'll usually find a default statement at the end that catches everything else. And that helps you, again, helps you write defensive coding, safe coding practices so that you cover all potential cases. The right-hand side of this slide shows you that you can also use the switch statement with slightly more complex things. For example, here we're using ranges, right? Distance is defined up there as a constant with the let keyword of type integer, right? Because it's assigned the value 5 initially. And so now we can switch on that value because it's an int expression. And if it's 0 through 9, then we print one thing. If it's 10 to 500, we print something else. And if it's default, if it's anything else, we go through the default statement here. So this is how you can use entire ranges in your statement. That's just a modernization, I think, that makes total sense. Okay, so those were a couple things about Swift. There's of course, there's way more stuff to cover, but we wanted to get you started with a few simple concepts. This is just also the way that the textbook structures things. And now, what do you think, Phil? Maybe a 2-minute bio break and then switch over to the IDE? All right, yeah, we're going to take a really quick break. 2 minutes for you guys to get up, get some air into your lungs, move your body, energize yourself so you don't fall asleep. I know it's hard. Yeah, Heinrich's like, I don't want to get up. And so see you back in 2 minutes, and then Phil will tell you about the IDE. And I just want to say you are in really good hands with Phil, because he is an Apple certified trainer for iOS, right? So it's not just any Phil that's teaching you this, it's an iOS Apple certified Phil.
All right, so let's then start with an intro into Xcode. When you start Xcode, the playgrounds were usually already visible here on the main screen when you just start Xcode, but it has been pushed back a little to the file menu, so that if you create something, you can create a playground to easily test out code fragments, and also just create quick demos that you have. Of course, that always moves on the different side. And there are a couple of different levels that you can use. You can start with a blank playground, which we'll be using here, but there are also more complex elements where you can even use SpriteKit for graphics applications, or using frameworks like for maps and stuff like that. So that's really, it's not just simple code execution like you have in the terminal, but you can do a little more things here. But we'll focus more on the blank for now to just give you a first impression here.
And you're also using macOS, I think, right? Not iOS here.
I think so. Yeah. Let me see where I am here. I can navigate through. So we start with an empty editor here. If the font is too small, just let me know. I went to the presenter screen, but or presentation size, but might be too slow still. So if you start with a playground, the main part here is that you have your editor, and to see the output, you have just a small button here that you can also see if you printed out elements down here. So let's just try this. If I just print the greeting, then it will show up once I execute. And execute can happen in 2 different ways. I can just run everything up to a specific point, and it will run. At this point, takes a little while, even if it's very simple, and it will show up. And as Jan mentioned, also here on the right side, we have an overview that directly shows you what the line here evaluates to. So I have hello playground as an assignment to this variable, or hello playground with the return character if I print it out. But you can also set the playground to automatically execute everything you're just typing. So if I go to the button down here, I can set it to automatically run, and then it will always execute as soon as I type something. So for example, if I assign a variable here, so set let x to 1, you can see that it briefly had an error message down here because it couldn't execute everything. But as soon as I've stopped typing, you can see here that the variable is set to 1, and everything is running through. And one very helpful thing if you develop in Xcode or in the Playground, if you hold down the Option key and can then click on variables to get a brief explanation. For example, you can see what type Xcode inferred here. So you can see here that it is an integer. And if it's more complex elements, it will also give you more information about that. And we'll see that when we move over to Xcode. So now that I have a variable here, if I try to assign something new to it, then Xcode will also, or the Playground here will also complain, because I initialized here x as a let constant, so and I can't adjust this. And similar to throughout Xcode and the Playground, it will also offer you fixes for simple mistakes or for frequent mistakes. So here it says I can't assign something because it's a constant, and to change it, I can change it to a var, and then it will run. So if I fix it, then it changes here the let to var, and everything is running through again. And I can see now 2 is assigned to x. But what I still can't do is assign a double, for example. So if I have a dot here, yeah, that won't work, because the type is set to integer when I created it, and so I can't assign a double here. And a way to fix that would either implicitly say here that it is a double, or if I just initialize it with 1.0, then it will infer that it is a double, and I can assign it also 1.2 for it. If we create another constant with 2, and to combine what Jan already said, combining different variables is also dependent then on the type. So if I would just try to divide one by the other here, x divided by y, this will also not work, because while x is now inferred to be of type double, y is inferred to be of type integer, and I can't combine them here. And what I could do here is to explicitly cast one to fit the other. So for example, if I want to specify that y should be treated as a double, I can just write or put it in parentheses and cast it to double, and then z will be also equate to a double type. I can see here that it is in 0.6. And similar for text as well. So if I just have create a string here, ABCD, I have now a variable here that I can print out, add new elements to it, and there are different ways I can, for example, now add the e to that string. And easiest way is then also to use the different methods that string gives to you that you can use. So if I just type the variable name and use the dot, I get a list of all the functions that I can now call for this variable. So there are different ones to go through. String has a lot of different ways. And if I just want to add something, I can append a new string to that. So if I just want to add the E to that, this will now change the text so that it is now also ABCDE that I get to the. And so if I want to print the text out, print is usually the easiest way to start there. And I want to combine it now with our variable Z that we computed before. I can't just use the plus Z option because they still have different types, so a string and a double that I can combine. I could try to cast it here to a string so that it is added there, or the or more frequently used version, if I want to type out or print out different variables, that I use the string enclosure that I have the backslash and around the variable, then it will print out that variable directly in our in the string. So here I have my normal string ABCDE, and then I add to that a comma, space, and then this just prints out the value of our variable there. And so that very briefly just showing what you can do in Playground, and really easy to test out a different code fragment. So for example, for the questions that I saw in the Zoom chat, this is a good way, just copy the code in here and just play around with the variables if you want to see what happens if, for example, for the switch ranges, if you enter 5.5, what will happen, and you can there really quickly test out different variables for your code.
By the way, Phil, I saw somebody, Jan Borda said that making the font a little bigger would be cool because he's watching from the mobile. So I'm assuming his nose to the display at this point. So then
let's go even larger. Does that work? That will now be. It's fun if there's more code then on the screen. We'll see that. And for the Xcode environment around you, that still might be a little bit small, but I will explain what we're looking at. So if we want to, or the most project that you will be working on if you develop for iOS and also want to make use of all the frameworks, the simulator and stuff like that, you will usually then create a project. So, and for that, you also have different aspects to or ways to choose from. We'll develop for iOS mostly here, but you can also use Xcode Develop for macOS, of course, for watch apps, for tvOS on an Apple TV, or multi-platform apps that you can run on different systems. So if you create an app, you always need to give it a name and also specify the team or the developer profile that you will be using. So there are different profiles. There's a paid profile that you need if you want to submit apps to the store. But for private usage, you can also have a team that is just for private development, allows you to release on your device, but you only have a limited set of apps that you can release there. So if we would just want to develop an Xcode demo, yes, the identifier, let's just make this there as well. And the interface defines how you want to lay out the UI of your app. So Storyboard is the one that is mostly used today, but Swift UI allows to use a declarative approach to specify your UI, while Storyboard is a layout version that we'll also see in the demo later on. For the language, you can still use Objective-C, but Swift is now the main programming language that you use for iOS and Xcode. You can directly include tests or use core data for persistent storage. But yeah, we'll not look more into that today. Need to specify where you want to head it. And you can also directly create also versioning control that you can use in Xcode to work with multiple users or track your changes, track the different versions that you have. So, and if we create the new project, then we have here the Xcode window for projects. And we'll start here in the main settings that we have. And this window is generally always split into 5 different areas. The main here in the center is used for code editing or specifying the settings of your project. While you also lay out your UI in here when you use the storyboard. And the toolbar here on top, that is used where you can compile and run your application, or also specify where you want to run it. So for example, for a simulator, you have a lot of different device sizes or capabilities to choose from. So if you want to use the iPhone 13 mini, you can start the simulator running on there. See the state, whether it's ready, compiling, or building, or you have to, and you have different buttons to adjust which elements of the UI is visible at the moment. Then here on the left, you have the navigator, which is mostly or mainly showing the different files that you have in your project. That is here the main view, but there are also different tabs here to see when there are different elements in your versioning control, what types of symbols you're currently using, what methods are there, what functions are you using. You can search and replace, of course. And when you're running, there's also, for debugging purposes, you can see here the consumption of space and stuff like that. You also have tests. If you have something, you can see the state there. What are the debug sessions there at the moment? What sort of breakpoints are you currently active in your project? Or what happened maybe in the last the history? What did you change? So this will also adapt automatically to what you're doing, to whether the code is running and so on. So, but this is giving you a lot of information about the state of the project. Then at the bottom again, you can show the console where you have. I will also show it once it's running. Have the output of the console. If you print something, it will appear here, and if you're debugging the state of the app, will also show here in the bottom. So that's the debugging area. And the final area here on the right is the utility area, where you have settings that you can specify for your project, and you have the information that will depend on what you're currently doing also there in the editor. So even without changing anything, if I click on the play button here, it will now compile the app and start the simulator and run the app within that simulator. And this will now take a while, and probably we'll start it on the different screen again. No, it starts here. And the simulators are also quite powerful, because they're essentially encapsulating all the device's capabilities, and that you can navigate through that and test out how the device is behaving. So now we have a just empty screen, but all the gestures that you would usually have on the device also work. So if I swipe up here from the bottom, I can go back to the home screen, and you can see that there are. It looks just like a simple device. I have my settings that I can specify and run and interact with it normally like on a device. But of course, not everything will run on the simulator. So for example, camera usage, accelerometer, gyroscopic data, that will all not work. So it is something that where you have to use an actual device to play with that. So, but if we select here the view controller, that is essentially the starting point where you can input elements for your app. Let's just put that to the side. And for the different levels of help that Xcode also providing, let's see if I just create a string. I never use this. Xcode will interpret what you're currently using in your app. So if I define a variable or a constant and I'm never using that, Xcode will give me a warning that I'm never using this variable, and if I really want to do it that way. And warnings, as in other programming environments, they don't prevent you from running your app. This will still run. On the other hand, errors, if I now try to change it, will prevent you from actually compiling and running the app. So this is then an error. And if I try to build the app, this will not work. So it will crash here. And I already mentioned in the playground demo that you have also a lot of different documentation available. So if I hold down the Option key on my keyboard and click on this function, I get a summary of what this function actually does. And I can get a brief overview of what it helped. But if I need more help, I can open it in the developer documentation. And the developer documentation also comes with Xcode and is quite extensive and has a lot of information that you can directly then use. For example, if I just select the view controller, I have a big overview of what everything is taking place and how the notifications and the functions are passed along. And there's a lot of the functions that you're using. But there are also programming guides for the frameworks, for example, for Medkit, that are online that also give more examples and demo code that you can use in your app. So, but for the UI, if I select here the main storyboard, this will open the storyboard. Let me just quickly zoom a little bit closer. That is the UI that we have on our screen. And I can use, not that one. No. I can use this storyboard to lay out my UI. If I, for example, press the plus button here, I can just drag a label and put it here in the center of our screen. And can just use the lines here as well to arrange it, but why did that? And you can see here now, if I selected that label, the utility view here on the right gives me all the different options for font size or the different layouts that I can use. I can all of do that from code, but for specifying your UI, that is also quite helpful. And if I want to add a button, it's just the same way. And Zoom and Xcode together is quite a performance issue that I see here. So I can also change the captioning of the button. The question now is, how do I interact, for example, with the button and the label that I have here. And how it works in Xcode, I have also the assistant view that I can select here from the menu. And I will essentially see then my UI and my code side by side. And to connect my UI with my code, I can simply right-click and drag to the code window here. So, for example, if I right-click and drag from the button to my code, I can specify, okay, this should be an action. So I want to be notified. This should be executed when I'm pressing that button. So let's just call this button pressed. And can also specify on what event, whether it's whether the user releases while touching the button, or when it's just touched down on the button. I can directly specify this here. And then I connect it. And the code that is created has the form, the IB action keyword that specifies this is something, an action that is triggered from my UI. And this is also creating this circle here that is connected to my button that I can see here. Func just specifies I want to create a function, button pressed is a name, and what is in the brackets here is just the parameters that are passed along. And we will get to them also in a future lecture. So, but now if I want to change here the label that I actually change it, I need the link back from my code to my UI. And that is something that I can also just do by right-click and dragging the label to my code. And this is now creating an outlet. The outlet is the direction from my code to my UI. So if I want to say this is the text label, give that a name, and again, click connect. And now I have here the keyword IB outlet, which is specifying this is something, an element in my UI. The keyword weak, something specifying about the relationship between that variable and the view controller that we have. We'll also get into more details there. Then you know the var keyword already. Text label is the name, and UI label with the exclamation point specifying this is an optional UI label. But with the exclamation point, I'm making sure I'm saying, yeah, this is existing. I don't need to treat this as an optional here. So now what I can do is in the function that we connected, I can just specify that I want to change the text of my text label to say, for example, hello iOS class. And that, if we run this, will compile then for a simulator. And now if the UI starts here, I have our label, I have my button say hello. And if I click that button, the label changes to hello iOS class. But as you can see, this doesn't really look like exactly what we have here in our UI. That is because there are different sizes that iOS devices come at the moment. And here I placed it in the center that we have here, but at the moment it's set to an iPhone 11, or the screen size of an iPhone 11. It's something I can adjust here, that I view my UI in a different device size, but to really make it adaptable to every device size, you will need to use something such as auto layout, which will also cover, which is used to make sure that your UI looks good, and you can control how it looks like on every different device size. So that is a very brief intro into Xcode and the different elements here, and we'll get into more detail also, or we'll see it again in, of course, in future lectures. But for now, let me switch back to the slides, and also for me to switch back.
I'll just say, Phil, real quick,
yes.
as an intro. There was one interesting question that came up in the comments here, whether you could import your Figma prototypes into Xcode. And Max actually found a solution to that and posted a link in the chat
Perfect.
about how to do that. SwiftUI.ai, I think, is the tool to do that.
Okay.
But we haven't been using Figma, I think, heavily at the lab, as far as I'm aware.
Not that I'm aware of. Yeah.
All right, and we should also say what we're doing here mostly from now on, for most of the class, is actually talking about UIKit based app development. So we're going to mostly be talking about how to write full-blown apps that can use all the various advanced things that iOS provides and that the hardware provides and the OS. We will talk about SwiftUI as well. And I would love to get you guys all just started with SwiftUI and say this is it. It's a wonderful environment. It's really elegant in its ways. It requires you to completely rethink how you code, and we will be covering it. Right now, it's not quite ready for prime time, I would say. The devil's in the details, as always. But so you will be, I think, if you understood UIKit, SwiftUI will require you to just basically reboot your brain once, but then it will be super easy, because honestly, coding in SwiftUI is much easier than coding in UI using the UIKit APIs. And so you should be all ready to pick that up as well if you would like to. And maybe a few years from now, SwiftUI will be the only way to go for everything. I don't think that moment is there just yet. So that's why we're covering UIKit, because sooner or later you will find yourself in UIKit land if you really want to fine tune your appearance and build sort of a super elegant app that works perfectly on a particular device class.
Yeah, no, that's true. Okay, so for the lecture content today, we are at the end. So quickly, what we talked about was just a basic intro into Swift and the language itself, what the data types, the type inference, and what is special about the control flow and different variable types in terms of tuples and optionals. And also I had a brief tour about Xcode, the development environment. And next lecture, so tomorrow, we'll continue going more into detail into strings, structs, and classes, and we'll cover that then there in detail. But today we'll also talk a little bit about the seminar. So
Phil, there's another question. I just wanted to answer that here for everybody, because it might be universally interesting. Brian was asking what the best recommendations would be to follow what we're doing here using the books. The class is mostly structured following the textbooks in fairly direct order. So we originally had a different format for this, because this class is older than those textbooks actually, and it has been developing every year. We're rejuvenating it in a way, but we recently decided to actually align ourselves more with the book, because it's such a great resource to dive deep into anything you didn't quite catch or you want to read more about. So mostly you can just really literally look for those topics in the book, and they should be coming pretty much in the same order. Is there anything you want to add to that, Phil?
No, the books are a really good resource, because they're they're way slower than we are doing it here in class, but it also allows you to look at things more clearly. They go way more into detail about different components of the language than we can do here, or we want to do here, because we want to give you a good overview in the time that you can start developing your own app. But if there's things that we present here are a little bit unclear, look into the books, because they have a good explanation. And also what is they're really helpful at the end of each section chapter that they have, they have a more extensive demo, coding demo or coding project. And it's something that is quite helpful to just work along. So read what they're doing, but also try it out in Xcode to get a feeling of the different environments there. But it is something that is gradually building up. So it's a good way to get started and to repeat and rehearse what we've been talking about.
Yeah, I think as of this minute, I think those documents are still about Xcode 12. So you may find a few things looking just slightly different, but I think this year, there's nothing too drastically changed that would totally throw you off. No. Oh, one more question here, Phil. Din's asking, are we allowed to use SwiftUI for our project?
Yes. We
did that last year, right?
Yes. Yeah. I mean, it's also something I will now talk a little bit about, because it's also applicable for the seminar. So for the seminars, we will have then, once the seminar part comes around, 2 presentations per session. And a presentation will be that there's a 15 minutes presentation from a group about the specific topic. And then we'll have roughly 10 minutes afterwards for the discussion about the topic. You already formed your groups of 6 people. And this is just listing the dates where we will have the presentations. You will need to have a finished version of your talk ready 1 week before you need to present, because that 1 week before will have a feedback meeting where you already show us what you will be presenting and what you will have, so we can give you some feedback 1 week before that you can then implement and include for your presentation then the week after. And those feedback sessions will be after the presentations of that session. So that meaning for most of you, if you're not presenting, you have 2 seminar presentations, and then 2 groups will have a feedback about the presentation that they're giving then the next week. Now, the order of the topics that we'll present to you, that's not finished yet. So don't pick a late topic and think that you have more time. We haven't set the order there yet. That is still in the works.
Also, while SwiftUI is fine for picking seminar and project topics, there will be questions about UIKit, and a lot of them in the final exam. So you can't quite skip your UIKit here. And we'll be covering UIKit, of course, in much more detail than what we'll be doing in SwiftUI. And I expect over the coming years this to gradually change maybe that balance. But right now, that's what we have to give you the best sort of practical advice for coding.
Yes, but a lot of the frameworks, they are more on the coding level, what you need to implement there. So for your demos and also the project later on, you can decide whether you want to use UIKit or SwiftUI. I'm usually more in the UIKit camp, while Jan is often more in the SwiftUI camp. So you can decide what feels more right for you. But what you should have in the seminar, really give an overview of the framework and the structure of that framework, but don't just list the API or just held down the methods that you can use there, but rather focus on how can this framework be used to solve a problem elegantly. So where does this framework actually make something simpler, and what is now possible using that framework? And the structure, since 15 minutes of a presentation is rather limited, a suggestion what you can or what you could follow for the talk is just to have a brief introduction and motivation about the framework. What is the problem that it is addressing, and what is the general structure that you have there? And then just basic steps, what you need to do to actually use the framework. So a couple of the framework really require you to have a specific setup. What is that? What did you need to do? What is the basic setup so that you can use the framework? And then also go into one or two advanced features that are really interesting that this framework now allows you to do. For the demo, show what you have implemented using the framework. The time for live coding will be probably a little bit limited, but if you also can manage that, that's also fine. But really also have a demo, code demo of different elements. How did you solve there maybe a particular problem that you have? And what you need to hand in for the seminars will be the slides that you're presenting, and also the demo code, which will then also upload to Moodle so that everyone can have a look at that. So now, since the time is running out, I will just go briefly over the topics that we have selected and let you know how you can pick a topic or specify your preferences there. So the first topic is core animation, which is about drawing and animating elements that you have on the screen. We'll also listed a couple of things to look at on the slides, which I will upload to give you a starting point. What are maybe interesting parts of the framework to focus on, to give you an idea what you can do with the framework, or what you can should look into. Then there's haptics and sound. So sound playback and sound control is something that you will often do, and there are now also a couple of different ways to give tactile feedback to the user. So here your demo should show how you can combine that. Maybe a player that is also available on the lock screen, and when you press a button, you get the tactile feedback of that. That could be something to look into. Core image and core image filters allow for fast image processing and analysis of what is in the image. So you can quickly apply different visual enhancement to video and photos and control the intensity of those. SpriteKit is for 2D games that you can use to create visual top-down games, or have some physics visualizations in here, and it's used on in node tree structure, different scenes and actions that you can control. And here maybe something that shows the physics capabilities and how you interact with those. Then there's the topic about working with files, because it's not just that simple to store files and how you can interact with those. So in this seminar topic, look at the different ways to store files and browse files, and maybe also how to hand them over to different applications, or use files from different applications, in what way that is possible. Combine allows for declarative UI creation. So this is something, look at how you can create frameworks or UI in this way, how you can use the Combine framework there, and what is the essential pipeline of different elements. Xcode already gives you a lot of ways to debug your code. There are breakpoints that you can set and just step through, but there's way more. So in this seminar topic, should also look at how can I print the objects in the console? What are there different ways that I can do? How I can debug my UI? How I can create or react to different breakpoints that are thrown when an exception is happening? How can I track memory leaks and so on? Some of those are directly in Xcode, while others are using instruments to track down the different bugs, codes that you have. With iOS, you can also display text in a lot of different ways. So for displaying rich articles, that is something, okay, how can I display HTML code or HTML in my app? How can I style the text that I'm showing? What are there different ways that I can control that? MapKit is for visualizing maps and locations and interacting with maps, and also displaying your own location using the location manager. How can I control that? How can I set this up? How can I get directions to a nearby location? How does all that work? For transitioning between different views, you have the UI presentation controller that you can use to really fine-tune how this transition looks like. So this is something where you can create your own transition from one view to another. CoreML and CreateML is about machine learning that iOS directly offers as a framework that you can easily use. And in this project, maybe focus more on image classification, showing how can I create or how can I adapt a machine learning framework, and how can I use it now then also in iOS. Core data is for more persistent storage. How can I lay out my different elements? How can I retrieve them? How can I search through them and just fetch a couple specific items? Watcher is for the development on the watch. And well, there are of course different design decisions. How can I lay out my UI on a watch? How can I use this rather limited space? But for this class, the more interesting element is how do I develop for the watch? How do I prototype my UI? How do I set up the connections? And what is the combination of developing an app for iOS and then also having the app running on the watch? What do I need to do? ARKit, yes, using augmented reality. What do I need to set up with the session and configuration? How can I use different anchors in the scene? How do I detect planes and detect what I am hitting when I'm selecting something on the screen? That could be something for this topic. While for Reality Kit and Reality Composer, that is something that is even making that even more simple. And you can look at how can I interact with the environment also for the prototyping of AR applications. And then the last topic is more advanced SwiftUI layout. We will talk about SwiftUI and the general concept of that. But in this project or the seminar topic, you can go even deeper and look at different ways how you can resize automatically and just show a beautiful SwiftUI created UI for your application. So those are the 16 topics that we've come up with for this year. And so now what are the next steps? For each group, please rank these different topics with from 1 to 16. And send that to me by Wednesday so that we can see how we can distribute the topics so that every group has the topic they're most comfortable with or something that they would like to do. Not everyone will get their #1 choice, but in the past, usually it worked out quite well that everyone got a topic that they were comfortable with. So that's something to do until Wednesday at noon. Send me then a mail, one per group, with the ranking, and then we'll let you know which topic you got for your group. And if there are any questions, of course, also just drop me a mail or ask on the forum online in Moodle so that I can react to that. All right. If Jan, you have a look on the chat, are there any questions about this at the moment?
Not well. There's one thing: presentation templates. Whether there's something coming up for how to design your presentations.
For these, just use a template you're comfortable with. We don't have a template that we're here enforcing. We can make our keynote template available to you. We don't have something for PowerPoint though, but that you're welcome to use it, but you're not required to.
Right. At least that's what we handled it in the past. And there was a question by HKD about presentation distribution, whether everybody should be speaking some during those 50 minutes. This is usually a very good idea, because one of the things that we did this year in doubling the group size to accommodate more of you folks to be able to take this class is that it will be really tricky for us to judge individual contributions. So we highly encourage you to divide your speaking time up between all your members of your team, so we can see already that everybody knows what you've been doing and what you've been up to. We will still ask a few questions randomly at just to probe whether everybody's been engaged in the project and knows what's going on. But yes, distribute your time among the presenters. That's usually a very good way to show that you've all worked on it.
Yes, but it's also something, I mean, for 6 people per group and 15 minutes, that's not a lot of time. So be also sensible about this, and just so that one of your members is saying, hello and welcome everyone, and then you're switching, won't really make much sense. So we're not enforcing that everyone needs to say something. If it works out for you, if you have, you can distribute the presentation time that it works out, fine. It's more important that for the question time afterwards, everyone is prepared. We will not ask the guy who was presenting a specific topic a question about this, but rather ask the rest of the group as well whether they know everything. Since for groups of 6, it won't be really easy, or it will not be possible to really judge individual contributions, which also means if you have problems within your group where you say, okay, one guy is actually not contributing at all, or we can't reach him, it's not doing anything, let us know. We will not be able with so many people to see that. If it's smaller groups, it's generally easier to spot something like that, but we will not be able to do that reliably here. So if there are problems, just let us know. And to ask the question about the supervisors, it will be independently for most of the time. There will not be multiple meetings as a seminar structure. Seminar just means you're presenting a topic and presenting it here. Will not do any presentation coaching in terms of how to best present it. It's something you have done in other seminars. Here it's really more about the topics and the content that you have. So we'll only have this one meeting before, 1 week before you're presenting it. If there are questions coming up where you say, we absolutely can't find anything for this topic, drop us a mail and we'll get to it and see what we can do.
There'll also be additional people engaged at that point. Sebastian and Adrian will be joining the task force here, and will be your points of contact mostly for the seminar, likely. So and then there's another person. Sebastian has also gone through and is an Apple certified iOS instructor, but he also knows iOS in and out. So another great person to learn good iOS coding practice as well.
Yeah. And about the question for resources about the topics, there's usually also the names that I've mentioned on the slides, either the topic names or in the things to look out for. If you just Google those names, you will get the Apple documentation regarding these points, and so that will give you an idea what it is about. So you can check that until Wednesday to structure your preferences for the topics. I will upload the slides into the Moodle room today, so you'll have all of those information there.
Another point that is usually super useful is if you're more of a video person, again, the WWDC videos about a particular framework are often very illuminating. And if you can find them, it often makes sense to go back to the year that framework was introduced, because that's usually when they gave you a really like 101 kind of style of introduction of this is what we meant with this framework, and this is what it does, and this is how you're basically using it. And those are usually great finds. And that would be the WWDC videos that you can get through the Apple Developer app.
Yes. Okay. And so now this was a little bit longer to go over the seminar questions. If there's still something that is unclear, just let me know and I'll get to it. And yes,
deadline for when topics arrive, I think.
So yeah, send me your preferences, one ranking per group by Wednesday at 1, and we'll then do the assignment of the topics, and hopefully by Wednesday afternoon I will have it. If it's very complex and you all have the same structure and need to see what is the best distribution of topics, then it will be a little bit later. But I mean, the topics is still a little bit off. Yeah.
And I want to second Johannes' recommendation, especially hackingwithswift.com is a great website, a third-party website by a guy who I don't know what he's doing apart from writing Swift tutorials all the time. Great learning resource that gives you a chance to quickly dip into what is this all about and what does it do.
Yes, and Ray Wenderlich, of course, as well. Very good tutorials that are also regularly updated. So to work.
Right on.
Cool.
Thanks, everybody.
Thank you. And then see you all tomorrow. Bye.
This content was provided by RWTH Aachen University.